So what we're going to be doing moving forward is we're going to be finding some trig functions of real numbers. So when we're finding a trig function, finding a real value, finding a solution, we're going to be given some information, and we can either use that information to, sometimes it'll be easy to just type it in a calculator. It's not going to be super often that we have that, but it's going to be a thing we can do sometimes. But it's also going to be that we're going to use either the triangle or the unit circle to put things together. All right. So I'm just going to see if I hear mics come on. I just kind of mute them from my end. If it makes it so you can't ask a question, please feel free to let me know. I'm still figuring out Teams. I'm really well versed on Zoom, but Teams is new to me. So we're figuring it out. But what we're going to be doing, working with our trig functions of real numbers and of real values, is we're going to give you information, and we're going to use that information to find our trig functions. And I'll show you what I mean here in a second. Sometimes we'll be given a point. Sometimes we'll be given an actual angle. Sometimes we'll just be given a number. And all it means when we're given a number is that it's the same thing as the angle. There we go. Okay, cool. Awesome sauce. All right. So we're going to start with looking at an ordered pair. We had some like this in the last section. We didn't do tons with them, but I want us to look at this one. So I've drawn myself a little grid here, and I put a circle on it. You don't have to have that. If you want to draw it, you can. What we're looking at here is we are looking at the point -3/5, -4/5. So we can think about that being in quadrant 3, because they're both negatives. So we know it's going to be down here in quadrant 3 somewhere. And if we have -4/5, or sorry, -3/5, if I was to divide this thing into like 5s-ish right there, so we'd be about here, and then -4/5, it gets us a little bit closer, but it puts it right down here. So this is our point, -3/5, -4/5. So we've got our x and our y. Well, if we want to be able to look at the angle that's created here and find our trig functions, we need to find that r, that radius, that distance from our center, from that origin to the point we have on the circle. So we can either use our Pythagorean theorem, or we could notice a few things about this triangle. Either way. So I'm going to go with the Pythagorean theorem style, where we take and find our r. We know r squared is the same thing as our -3/5 squared plus our -4/5 squared. And we can find our r that way. So r squared is going to be our -3/5 squared. That's going to give us 9/25. And -4/5, that gives us 16/25. Because it's the same thing as if I square the top and square the bottom. And 9 plus 16 gives us 25, so our r squared is the same thing as 25/25, which is just 1. So that means our r is just 1. From here, we can get all 6 of our trig function values simply because I know the angle, I know the x, I know the y, and I know the radius. So we know we're looking at this angle here because we're always looking at the angle based off of our x-axis. We're always looking for that piece right there, which it does have a name, which we're going to talk about tomorrow, what that little angle is called, but it gives us the vibe. So from here, we can get our trig functions for this angle. I'm just going to call this angle theta just because it's familiar. You could also call it P if you want to do that, because they named the point P. That's totally fine too. So you can either go sine of theta, or you could go sine of P. Genuinely does not matter. I'll go with a P just since they named it that, so I've changed my mind. I'm not going to call it theta. I'm going to call it P. And we're still looking at that angle though, and we're looking for our sine, which is our so opposite hypotenuse. So our opposite, that's our negative 4/5, hypotenuse is 1. So our sine is going to be our negative 4/5 over 1, also known as negative 4/5. Our cosine of point P, so CAH, C-A-H, adjacent over hypotenuse. So our adjacent is that negative 3/5 over 1, which is going to be the same thing as our negative 3/5. Sorry, there's a weird noise happening in my room right now. I don't know what's happening in my room, but doing a thing. Who knows? And then we're also going to do our tangent. So our tangent of point P, we can take our sine over our cosine. We can do our opposite over adjacent. Does the same thing. So that's going to give us our negative 4/5 over negative 3/5. And you're either going to do our keep, change, flip. We're going to notice that the fifths cancel out. The fact that they have that same denominator means this piece and this piece are going to cancel out. Either way. Or you can take our negative 4/5, keep, change, flip, negative 5/3. That's also valid. Either way, we should wind up with our negative 4 over negative 3, which is the same thing as 4/3. From here, we can get our other three trig functions. We know those guys. Those are our reciprocals. So my cosecant of point P, that's the reciprocal of sine, because sine and cosecant go together. So we're going to have our negative 5/4. Our secant of P, that's going to be our reciprocal of cosine. So that's our negative 5/3. And our cotangent of P is going to be our 3/4. So when we're given an ordered pair, we're given our adjacent and our opposite, and we either have to find our radius, we have to identify some pieces. We can do it as like a triangle. We can do it on our circle here. We can do any number of ways, okay? We can also notice that when we're given an ordered pair, we have our sine, that's my y, and my x, that's my cosine. Then we could do sine over cosine and get there. You don't even have to plot the points to get there, because our x is cosine, our sine is y, because they're in alphabetical, cosine then sine. That's the way I remember it, cosine's first. Okay, so sometimes we'll just be given an ordered pair to find all of our pieces here. Our other option is sometimes we're going to be just given a number. So sometimes we'll be told to find our trig functions of a number. They've given us here t equals 0. So what that's telling us, this real number here, when they're telling us t equals 0, that means that's our theta. That's our angle 0. So if they're talking about angle 0 or radians of 0, it's the same thing. So if I say sine of 0, that means sine of 0 radians. It's that angle. So if we think about that in terms of our unit circle, where we have our 0, we normally have our initial side right here, angle 0 is this guy right here. Remember, I've told you when we were looking at our unit circle on Friday, I don't care if you label it as 0 or as 2 pi, it means the same thing. They are coterminal. So this 0 is the same thing right here. And we're looking at this ordered pair here, where we're at the point 1, 0. That gives us information. So our angle is 0. Think about it on our unit circle. It gives us the ordered pair, 1, 0. That's all we need to be able to get our trig functions. This gives me my cosine and my sine. I can get everything else from that. So we're going to have our sine of t, or sine of 0. That's right, this says sine of t, just because the parentheses are a little annoying. And that's going to be our y from our ordered pair over here. So our sine of t is 0. So sine of 0 is 0, sine of t is 0, means the same thing. And if you have a calculator in radians, which I'll show you how to do it when I've got you with me, because it's just easier to do it when we have them in front of you, I can show you how to switch your calculator into radian mode, in which case you can type some of these into the calculator. So we know that our sine is 0, then let's do our cosine of t, and that's going to be our 1. That's our x value, because it's cosine and then sine. And so tangent of t, we know that tangent is made up of sine over cosine. So we're going to have our sine over cosine. So those identities can help us figure this out, because we don't even have to do anything with the triangle. I don't have to do anything else with it. I know sine over cosine gives me tangent, which means 0 over 1. My tangent is 0. So then when we're coming to do our reciprocal identities, or our reciprocal pieces here, we can use the reciprocals of the pieces that we know. We just have to be careful, especially with those zeros, because we have our cosecant of t, which is the reciprocal of sine. Remember that sine is 0 over 1, because 0 is a whole number. So when we take our reciprocal, we get 1 over 0, which is undefined. So our reciprocal of cosine, giving us our secant, well, that's 1 over 1. That one's a whole lot easier to do. That one's just going to be 1. And then our cotangent of t, that's our reciprocal of the 0 over 1. That's our 1 over 0. And again, we get something undefined. So we are going to have times when we get undefined values, and we're going to have times when we get defined values. And sometimes we'll just get numbers for everything. Okay. If you have questions on any of these, please feel free to toss things in the chat, or raise hand, or you can unmute if you want to. We're going to do another one. Very similar. So now we're given that our t is 3 pi over 4. And we're going to start to use our unit circle to help us remember some of these things. So we're thinking through our unit circle, looking at 3 pi over 4, and what I want is our ordered pair. So 3 pi over 4, if we think through our unit circle, we're used to this guy's our 0. 3 pi over 4 is very clearly a radian, so I'm thinking about my radians. I know pi is over here. This is my pi over 2 at the top. So normally we would have our 3 pi over, or our pi over 4 is the halfway here. That's our pi over 4. So this guy's 2 pi over 4. So 3 pi over 4 is this one. It's the middle. It bisects. Just pull out that old word. It's halfway through this quadrant over here of our 3 pi over 4. So when we're thinking about our ordered pair for this piece, if we did this with our 1, 2, 3, 3, 2, 1s, this was our 1, 2, 3, 3, 2, 1. This guy was our square root of 2 over square root of 2 for both of these. So the ordered pair on our positive quadrant is our square root of 2 over 2, square root of 2 over 2. All of our over 4s have that particular style when we're filling in our unit circle. So that means my 3 pi over 4, the difference between this guy and this guy is that the only difference is my x's are negative now. So this is my negative square root of 2 over 2, positive square root of 2 over 2. So whatever logical process you go through to get there, whether you fill in the whole unit circle, whether you have 3 pi over 4, just straight up memorize, that's fine. If you logic your way through it the way I just kind of described it. However we get there, we want to be able to find that ordered pair, because this is the guy we're looking at right here. We're looking at 3 pi over 4, where I have my cosine as my x, and I have my sine as my y. That gives us the information we need in order to find all 6 trig functions. We don't have to draw the triangle. We can, but we don't need to. If you want to, we've got our cosine, which tells me my opposite, or my adjacent over my hypotenuse, and my opposite over my hypotenuse. You can totally do that. We're going to look at an isosceles triangle at that point. Honestly, I think the ordered pairs are a little bit easier to go with, but that's me. So if we know the ordered pair, I know my sine. So sine of t, that's my y's. So that's my square root of 2 over 2. Again, if I know my ordered pair, I know my cosine, because that's my x's, and that's my negative square root of 2 over 2. From there, we can get our tangent of t, because that is my sine over cosine. So we're going to do our negative square root of 2, positive square root of 2 over 2. The sine is on top, sine over my cosine, my negative square root of 2 over 2. And really what those are is those are pretty much identical pieces. Square root of 2 over 2 and square root of 2 over 2 are almost the same, it's just that one's negative. So this is the same thing as negative 1. You could also do that as a keep, change, flip situation. We could have that our over 2's cancel out. We get square root of 2 over negative square root of 2. That would also work and get the point across that way. But we find all 3 of those pieces, and we can then use those pieces to find our reciprocal pieces. So we use our sine to find our cosecant. So our cosecant of t, that's our reciprocal of sine. So we're going to have our 2 over the square root of 2, which we are then going to have to rationalize because that's gross. We don't do radicals in the denominator, so this is going to be 2 square root of 2 over 2. Lots of 2's here. And it will simplify. My 2 over 2 will cancel out. So this is the same thing as square root of 2. So cosecant of t is our square root of 2. So secant, by a very similar process, we would go from negative 2 over square root of 2 all the way down to our negative square root of 2 when we get that all the way rationalized. And then our cotangent of t is going to be the reciprocal of negative 1, which is negative 1. And it's the exact same vibe whether we're looking at these positive angles or looking at negative angles. If it goes around a few times, we're just finding that same place. We're finding that same terminal side. So when we're looking at, especially if you're looking at the homework for 6-3, sometimes it'll be a coterminal angle. Sometimes it'll be a negative angle, so you're still looking for those coterminals. So whether it goes around a time or two or whether it's just coterminal right there at it, I want to make sure that you guys have the time to look at that. Okay, So we're gonna keep working with these points, and tomorrow we'll work with a couple more of these points just together so that we can go through some together, because I know on here is super duper awesome, and our most favorite way to learn math is on e-learning days. It's the bestest ever. I know that's so much fun and our favorites. But I wanted us to have that information and kind of go from there. I'm gonna go with, let's prepare for quiz 1 to be tomorrow. I will have discussions with Miss Blaze because we'll make whatever our quiz is going to be the same. More than likely, it's that we'll do quiz 1 tomorrow, and we'll just continue on after that and just pushing it back a day. So make sure you're going through that review, checking through that stuff. I will try to get all of our dates updated. I also don't want to take us right up to the end of our non-bell period. For homework 6-3, there's a whole bunch of questions to cut. Mostly because they have a whole bunch of graphing in this section that we're not ready for yet. We're going to do that when we get to 6-5. That's where we have all of our graphing stuff, is in 6-4 and 6-5. No, sorry, it's in 6-5 and 6-6. So I didn't realize there was a whole bunch of graphing questions in here. So those will all be in our 6-5 homework, which we're going to do on a worksheet. So anything after 24, you don't do, because it's based off of graphing, which we're not there yet. We will be, but we're not there right now. And I didn't feel like pushing the graphs forward, because ew. So there's now only like 6 questions on 6-3. We're going to talk a little bit more about 6-3 tomorrow. And then we'll get into 6-4 probably on Thursday. And so we've currently got it scheduled for our next quiz. It's honestly scheduled for Friday, but more than likely that's going to be Monday next week, just logistically. I try not to do 2 quizzes in a week. It can happen, especially when we have weird day shifts like this. I will let you know as soon as we make that choice. We are going to do our quiz 1 tomorrow. First unit circle quiz is on Thursday. Okay, so you're getting yourselves ready. You guys have 3 minutes till the end of the period. If you guys have questions today while working on stuff, feel free to reach out. Canvas, email, Parent Square. There's a student version of the app called Student Square that's meant for y'all. But those are the ways to get a hold of me. Please do not forget to register for the IU portion of this class. You should have an email from acp@iu.edu. That'll have a direct link for that. Otherwise, you can click on the link on the Canvas page, or you can go to the tinyurl.com/iubieschke, and it should take you to the registration page. Otherwise, it takes you to the ACP page. At the very bottom, there's a link for the registration. So make sure you do that. Work through some stuff. Send me questions if you got them, but you got 3 minutes at the end of the period. Do the thing. Let me know if you guys have any questions.